Linear relationships. When two quantities change by a constant proportion, quantities are said to be in linear relationship, and their graph is always a straight line. This means that for equal amount of change in the first quantity, the second quantity must change by an equal interval. So let's find out for all the three given data sets whether these relationships are linear relationships or they are not linear relationships. For first data set, which is in fact the cost of printing books. For 0 books printed, there is a fixed cost of $60. That might be setting up the machinery or labor cost, whatever. Like $60 is a fixed cost even if we don't print a book. And for every 2 books we print, there is an additional cost of paper or whatever of $6. So if we look at the number of books being printed here, the books increment by 2 each time. So the first variable or the first quantity is changing by an equal interval or by equal amount, and that is 2. What is happening to the second quantity? Second quantity is changing by equal intervals of 6. So every time there is an increment of 2 in the first quantity, there is corresponding increment of 6 in the second quantity. This fits perfectly well with our definition of a linear relationship. That's what exactly we mean. That for equal amount of change in first quantity, the second quantity must change by equal interval. So if the first quantity changes by 2, 2, 2, 2 and 2, the second quantity is changing independently by equal intervals as well. The intervals of the second quantity doesn't have to be the same the intervals in the first quantity. So don't be misguided. Those intervals are independent. Their length is independent. Whether they are increasing or decreasing, that is independent. The intervals in the first quantity, those are independent. But for the equal intervals in first quantity, there should be changed by equal intervals in the second quantity. And then that way we can say that the books and the price, the both variables or the both quantities have a relationship which is a linear and which could be represented by a straight line. Now let's take a look on the second data set, in which two quantities, the supply and the prices, those are the two variables, and we can see that the supply variable, there is a change every time happening by 5 units. So how big or small this data is, but the change is by 5 units always in this variable. So for every change of 5 units in the first, there is a decrease of 15 units in the values of the second variable, and you can see that this decrease is also constant. Every time for 5 units increase in the first, there is a decrease of 15 in the values of the second quantity. So this also perfectly fits well with the definition of the two quantities to be linear. So minus 15 and another minus 15. Therefore, we can say with utmost guarantee that supply and price are in a linear relationship because they obey the definition, or they follow the definition for the two quantities to be in linear relationship. For equal amount of change in the values of the first variable, the values of the second variable change by an equal interval. So for every 5 units increase, there is a decrease of 15, and that trend or that pattern continues all the way to the end. Now we take a look on the third data set, in which for time interval, the time is increasing by 2 units while the distance is increasing by 10 units. So for every 2-minute increase in the time, the distance is changing by 10 kilometers. So that's 2, 2, 2, 2 and 2. There is an increase of 10, 10, 10. So this is what we mean by the for equal amount of change in the first quantity, the second quantity must change by equal intervals. And we have seen in all 3 different data sets that for variation in the first quantity by equal amount causes change in the values of the second quantity by equal intervals. So all the 3 different data sets are representing straight line. And the relationship between the quantities in each data set is a linear relationship. And that linear relationship is going to represent a straight line. Now we want to answer another question which I have highlighted on the right here, that we want to answer which quantity varies independently and which quantity is dependent on the variation of the other quantity. Here again we are going to consider all 3 data sets, and we can see that cost of printing books depends on the number of books. Therefore, we say that the number of books is a quantity which varies independently, because that's up to us how many books we want to print. But the price depends upon the number of books that are to be printed. Therefore, this is labeled as dependent and number of books is labeled as independent. The price here for the second data set is also dependent, because the price depends on the supply. So, and the supply is independent. For the third data set, time is independent, and the distance, which depends on time. If the time wouldn't change, the distance would never change. If you are driving a car and you just if you are not driving, the distance wouldn't change. So your driving time if that doesn't change, then the distance wouldn't change. Therefore, time is independent and distance is dependent. It's very important to establish the identity which one of the 2 variations is an independent and which one is dependent, because the independent quantity or the independent variable will always be plotted on the horizontal axis, the x-axis. That's why if you are only given the names of the 2 quantities as x and y, x is always taken as the independent variable, and the y, which is along the vertical, that always is taken as the dependent variable. Anyway, the question number 2 has been answered as well, that which quantity varies independently and which varies dependently. And now we are going to find out m values and c values. For the m values, m value is equal to change in dependent variable divided by change in independent variable. Like the interval of change in means the interval and the interval here. So what is, if we want to find out the m value for the first one, what is the interval of change in the dependent, which is price? That is 6. And what is the interval of change in the first one? That is 2. And therefore m value is equal to 3. And if we want to find out the m value for this one, what is the interval of change in the dependent variable? That is -15. And what is the interval of change in the independent? That is 5. Therefore m value here is -3. And what is m value for the third data set? Here, which one is dependent is the distance. So the interval of change is 10 there. And what is the interval of change in the independent? That is 2. Therefore this is +5. So this is also called slope of the line that represents this data. And the last one we are going to find out is the C value. C value is the value of dependent variable which occurs against 0 of independent. Like when you take a look on the independent, where is the, which one is the number of books is the independent, and the 0 is right here. Against the 0 of independent, whatever is the value of dependent, that should be taken as the C value. So here 60 is the C value for the first data set. So for first data set, C value is equal to 60. And we should also take a look, what is the C value for second data set? That is 260, because that is the value against 0 of independent. So this is 260. C value for this is 260. And what is the C value for the third data set? That is 0 of time, and against, because time is independent, against the 0 of time, what is the distance? That is 0. So C value is equal to 0 here as well. So these are all the questions, and in next lesson we are going to learn how we can graph the two quantities using m value and C value.